Bismillahirrahmanirrahim. Our today's lecture is derivatives of trigonometric functions. Now I'm going to write down the derivatives of the trigonometric functions, which are 6 in total. So the derivative first, x sine kx is equal to cos kx into the derivative of the angle kx. So we get cos kx into k because x derivative is 1. The second function is d by dx cos kx, which I'm going to write now directly, minus sine kx into k. Similarly for tangent, tangent kx is equal to secant square kx into k. Then tangent dx secant kx is equal to secant kx into tangent kx, then k. K is actually in all the trigonometric function is considered as the constant value of the angle. D by dx cot kx is equal to minus cosecant square kx into k. And the last, d by dx cosecant kx is equal to minus cosecant kx into cotangent kx into the value of the derivative of the angle. Now these are the 6 trigonometric derivatives. Now I'm going to write down the equivalent for some certain trigonometric functions, that is tangent x is equal to sin x over cos x cot x, which is the reciprocal of tangent x. So cos x over sin x. Similarly, secant x, which is the reciprocal for the cos x, and cosecant x is the reciprocal for the sin. Now we are going to start few questions. Now we are going to solve question number 1 from the topic. Now here we have a trigonometric identity sin square x plus cos square x, and we have to find out its derivative f dash of x. Now we know that sin square theta plus cos square theta is equal to 1. So this question represents the same values, that is sin square x plus cos square x. So we can replace this value with 1 and f of x is equal to 1. Now taking the derivative, f dash of x becomes derivative of 1 whole divided by x, and we know that the derivative of a constant function is always 0. So 1 is a constant function, therefore its derivative is 0, hence f dash of x is equal to 0 is our answer. Now this is the very simplest way to solve the question, we can solve with another way, that solving or taking the derivative of sine square x plus cos square x individually. So see how we solve this question. Now we have f of x is equal to sine square x plus cos square x. Now we know that this sine square x is the power of the function and cos square x is also the power of the function, and we will use the formula. We use the formula y is equal to f of x whole power n. So dy by dx will be n f of x n minus 1, then the derivative of the function d f of x whole divided by d of x. Now using this formula, we can solve it as f dash of x is equal to 2 sine x d by dx and derivative of sine x. Here first of all we have taken the power of the function, that is 2 sine x, again plus 2 cos x d by dx cos x. Now 2 sine x, derivative of sine x is cos x, plus 2 cos x, and the derivative of cos x is minus sine x. So we can write 2 sine x cos x minus 2 cos x sine x. Now these two can be cancelled. We get 0. So the answer in both the cases will remain same. Which method suits you? You can use this method. Now next question. Question number 2. F of x is equal to cot x whole divided by 1 plus cosecant x. Now here we have two different functions. This is again f of x and this is g of x, which are being divided. So we are going to use the division rule as we have studied. So what is the division rule? Division rule is dy by dx is equal to g of x whole square, g of x d by dx, derivative of first function minus derivative of first function d by dx, and it is g of x. Now using this formula in this question, we can write as f dash of x is equal to 1 plus cosecant x square, and it is 1 plus cosecant x d by dx cot x minus cot x d by dx 1 plus cosecant x. Now taking its derivative, 1 plus cosecant x minus cosecant square x minus cot x d by dx 1 plus d by dx cosecant x and whole divided by 1 plus cosecant x whole square. Now minus cosecant square x minus cosecant cube x minus cot x. This is 0 because 1 plus minus cosecant x cot x and whole divided by 1 plus cosecant x whole square. So minus cosecant square x minus cosecant cube x plus cosecant x cot square x whole divided by 1 plus cosecant x whole square. Now we have f dash of x is equal to minus cosecant x minus 1 whole divided by 1 plus cosecant x whole square. So we can cancel this term as minus cosecant x whole divided by 1 plus cosecant x, and this is our first derivative for the given function. Now question number 3. F of x is equal to secant x whole divided by 1 plus tangent x. Now taking the derivative and using the division rule here, we have 1 plus tangent x whole square 1 plus tangent x d by dx secant x minus secant x d by dx 1 plus tangent x. So 1 plus tangent x, derivative of secant x is secant x tangent x minus secant x d by dx 1 plus d by dx tangent x whole divided by 1 plus tangent x whole square. So secant x tangent x plus secant x tangent square x minus secant x, this is 0, plus secant square x whole divided by 1 plus tangent x whole square. Now secant x tangent x plus secant x tangent square x minus secant cube x whole divided by 1 plus tangent x whole square. Now taking secant x common, secant x tangent x plus secant x tangent square x minus secant square x whole divided by 1 plus tangent x whole square. Now here we have an trigonometric formula which I am going to write is tangent square theta plus 1 is equal to secant square theta. This gives you secant square theta minus tangent square theta is equal to 1, and here we need tangent square x minus secant square x. So if we take minus 1 common, we get minus 1. This is, and rearranging tangent square theta minus secant square theta is equal to 1. So tangent square theta minus secant square theta is equal to minus 1. So now this we can replace in the formula. So we get secant x tangent x plus secant x minus 1 whole divided by 1 plus tangent x whole square. So secant x tangent x minus 1 whole divided by 1 plus tangent x square, which is our first derivative, f dash of x. Answer. Number 4, f of x is equal to cosecant x cot x. Now here we are going to use the product rule, which is dy by dx is equal to f of x derivative of second function divided by d by dx plus second function as it is, and d by dx means derivative of first function. Now in this question, the cosecant x is first function and cotangent x is your second function. So replacing all fx and gfx here, cosecant x derivative of x, that is cot x, plus cot x and derivative of first function, which is cosecant x. Now cosecant x and the derivative of cot x will be minus cosecant square x plus cotangent x as it is, and derivative of cosecant x, which is minus cosecant x cotangent x, which is cot x. Now your derivative is complete and just only simplification is required, which is cosecant cube x, and here we put the minus sign, plus minus cosecant x and cotangent square x. So dy by dx, which we can write as f dash of x, is equal to minus cosecant cube x minus cosecant x and cotangent square x. This is your required answer. Now question number 5, sin x into secant x divided by 1 plus x tangent x. Now we have to find out its first derivative. Now before finding the first derivative, we can see that the secant x can be replaced by its reciprocal, that is 1 over cos x, that is secant x is equal to 1 over cos x. For our simplicity, it will be more easier to solve the question. So f of x is equal to sine multiplied by 1 over cos x and whole divided by 1 plus x tangent x. This we can write it as tangent x 1 plus x tangent x. Now again we are going to use the quotient rule for this. F dash of x is equal to 1 plus x tangent x whole square 1 plus x tangent x, and derivative of tangent x we have to take tangent x minus tangent x as it is, and derivative of the second function, which is 1 plus x tangent x. Now 1 plus x tangent x, derivative of tangent x is secant square x minus tangent x as it is, and applying the sum rule, d by dx 1 plus d by dx x tangent x whole divided by 1 plus x tangent x whole square. Now secant x square, we are going to multiply the secant square x plus x tangent x secant square x minus tangent x, and the derivative of 1, which is constant, is 0, plus, now we are going to apply product rule here because x into tangent x, these are two different functions, so x will remain as it is. We take the derivative of the tangent d by dx, which is tangent x plus tangent x as it is, and derivative of x, then whole divided by 1 plus x tangent x whole square. Now secant square x plus x tangent x secant square x minus tangent x secant square x, which is the derivative of tangent x, plus tangent x as it is, and derivative of 1, which is the derivative of x. So 1 plus x tangent x whole square. Now we are going to just simplify the entire expressions that we have obtained. Secant square x plus x tangent x secant square x minus x tangent x secant square x minus tangent square x whole divided by 1 plus x tangent x whole square. Now this term and this term is cancelled, so we get secant square x minus tangent square x, this is tangent square x whole divided by 1 plus x tangent x whole square. Now we know that secant square x minus tangent square x is equal to 1, as we have already used this expression, so I am writing this equivalent. Secant square x minus tangent square x is equal to 1, so replacing this by 1, f dash of x is equal to 1 over 1 plus x tangent x whole square. This is the first derivative for the given function. Now question number 6. Find d2y by dx square, which means we have to find out the second derivative for y is equal to x cos x. Now here we have to take first derivative using the product rule, and then we will use the second derivative. So dy by dx is equal to d by dx x cos x d cos of x whole divided by dx plus cos x dx over dx. So x minus sin x, because the derivative of cos of x is minus sin x, plus cos x and 1. dy by dx is equal to minus x sin plus cos x. Now taking the second derivative, we write d by dx, which represents that we are again taking the derivative. dy by dx is equal to d by dx minus x sin x plus cos x. So d by dx minus x sin x plus d by dx cos x. Now for this minus x into sin x, we are going to use product rule. Minus x d by dx sin x plus sin x d by dx minus x plus minus sin x Now minus x cos x, because the derivative of sin x is cos x, plus sin x. Derivative of minus x is minus 1 plus minus sin x. So minus x cos x minus sin x minus sin x minus x cos x minus 2 sin x. So our second derivative is d2y by dx square is equal to minus x cos x minus 2 sin x, which is our second derivative. Now question number 7. Y is equal to tangent x and find d2y by dx square. So we take the first derivative, dy by dx is equal to d by dx tangent x, which is secant square x. It's so simple. Now taking the second derivative, d by dx dy by dx is equal to d by dx secant square x. So 2 secant x, then the derivative of the function. First of all, we have taken the derivative for the power rule, then we are going to take the derivative of the function secant x. So 2 secant x into tangent x. This now we are going to write as d2y by dx square, which is the second derivative secant square x tangent x. This is our answer for the. Now question number 8. In this we have to satisfy one relation in the question. Show that y is equal to x sin x is solution for y double dash plus y is equal to 2x. Y double dash means the second derivative of y. So first of all, we are going to take the first derivative of the given function. Y is equal to x sin x. So dy by dx is equal to dy dx x sin x. Here we are going to apply the product rule. X dy by dx sin x plus sin x dy by dx x. So x cos x plus sin x into 1. The second derivative dy by dx is equal to dy by dx x cos of x plus dy by dx sin x d2y by dx square. So x dy by dx cos x plus cos x dx over dx plus cos x. X minus sin x plus cos x plus cos x minus x sin x plus 2 cos x is the second derivative. Now using the given expression, that is y double dash plus y, we have to put the values minus x sin x plus 2 cos x plus x sin x. Now this cancels and gives us 2 cos x, which is equal to the right hand side of the given expression. So left hand side is equal to right hand side. Proved.